Hello everyone and welcome to Mathematics Schoolio. So in this video, let us solve a question from Trigonometric series. As you can see, it's an infinite series and the very first look of the question is not so good. But yes, if you use or observe the terms of the series carefully, then you will be able to use certain properties like the periodicity and the infinite GP ka sum that will make this question a beautiful, cute little problem of trigonometry. So let me share with you the method that we will use for solving this question. What we have to do is just have patience while reading the question, observe the terms carefully, and you will get the idea. Well, what is the question? The question says that you have to find out the summation of the series. So I'm just writing the series as S. How we are going to get the answer? So for that, first of all, let me write down what is S. They have given that S is equals to sigma K is from 0 to infinity. Numerator is trigonometric term, while the denominator looks as if it is a GP, right? When you concentrate on the numerator, particularly that cos k pi by 4 term, we know that cos term या फिर कहिए कि जो cos का function होता है, it is a periodic function. So I can say that it is a periodic term. And what is the period of this term? So you can see that the period of this term turns out to be 4 into 2 pi, that is 8 pi. So we can say that this function is periodic with period 8. This function is periodic with period 8 because pi is also involved now. So that pi will get cancelled and we will get the period of the function as 8. Now, if it is the period of the function, then I can say that after every 8th term, the same value is going to repeat. So I'm just going to write down now 8 terms just to show you that after 8th term, we will start getting the same numerators once again. Okay? So मैं sigma हटा रही हूँ. I will start keeping the values of k. Like keeping k is equals to 0 will give me cos 0 upon 2 power 0. This is cos 0 in the numerator. Coming to the second term, it will become cos pi by 4. Coming to the denominator, it is 2 power 1. Then we have cos 2 pi by 4, which is actually cos 0, or you can say cos pi by 2, that will become 0. So, okay, fine, that we will write. But abhi aage chalte hain. Cos 3 pi by 4, denominator 2 cube. Keep writing till you write cos 7 pi by 4 upon 2 raised to the power 7. Abhi 0 se start hoke humne 8 terms likh liya hai. Coming to the 8th term. 8th term is cos 8 pi by 4. 8 pi by 4 is nothing but 2 pi, which has the same value as cos 0. Next is cos 9 pi by 4. Abhi 9 pi by 4 means you can write it as 2 pi plus pi by 4. 2 pi plus pi by 4 means again it will become cos pi by 4, but denominator will become 2 power 9. Here it is 2 power 8. Coming to the next term, it will become cos 10 pi by 4. 10 pi by 4 means 2 pi plus pi by 2. 2 pi plus pi by 2, or you can say 2 pi plus 2 pi by 4. So basically what we are getting is 10 pi by 4 upon 2 power 10. That means the same terms we are getting once again. So infinite terms, what you can do is, you can make the combination of 8 terms at a time. Like I'm going to club these 8 terms together. Then I'm going to club the next 8 terms together. And like this, we will keep clubbing them up to infinity. Obviously, I will say that the first ye jo green wala encircled term hai ya whole expression hai, it will not be exactly similar to this one, but still there are similarities. Like the numerators we are getting are exactly similar. So what I will be doing now is just look at the series how I'm going to write. The first 8 terms can be expressed as sigma k is from 0 to 7, right? Sigma k is from 0 to 7 cos k pi by 4 upon 2 raised to the power k. Fine. Okay. Plus. Now look at the second encircled term. This second encircled term, we have the same numerators, but denominators differ. But how they are differing? What you are getting is, you just take 2 power 8 common from the denominator, and the rest of the term is again the same. Sigma k is from 0 to 7. Again, I can write it as cos k pi by 4 upon 2 raised to the power k. Similarly, the next term that we will be getting is of the type 1 by 2 power 16. Right? Because you will be writing 2 power 8, 9, 10 se lekar 2 power 15 tak you will be writing. So the next set of 8 terms will start with denominator 2 raised to the power 16. I have taken 2 power 16. Now numerators are same, so we will be getting the same term once again. K pi by 4 upon 2 power k. and you keep on writing it like this till infinity. Yani basically up to question almost khatam ho gaya hai. We need to take k is equals to 0 to 7 cos k pi by 4 common upon 2 power k. We are left out with 1 plus 1 by 2 power 8 plus 1 by 2 power 16. Keep on writing till infinity. Can you find out the sum of this infinite GP? Yes. Can you find out the sum of this 8 terms? Absolutely yes. So let us find out individual values and multiply them together. Like the first term, I'm writing this. So k is equals to 0 means 1 by 2 power 0. Then coming to the second term, the second term will be cos 1 pi by 4 upon 2. So 1 by 2 root 2, correct? Coming to the third term, what do we have now is cos 2 pi by 4, which is 0. So I'm not writing it. Now writing 3. K is equals to 3 ke liye cos 3 pi by 4. So I'll get it as minus 1 by root 2. So minus 1 by 2 root 2. It will get cancelled. Sorry, not 2 root 2. Denominator will change by. So 1 by root 2, but 2 cube we are getting. So 2 cube root 2. Coming to the next term, now we will keep 4. 4 means cos pi, so it will become minus 1 divided by 2 raised to the power 4. Keeping 5, cos 5 pi by 4 is again minus 1 by root 2, but along with that we have 2 power 5. And then we have 6. I'm going to keep k is equals to 6. 6 pi by 4 means 3 pi by 2. So no need to write, it will become 0. So come finally to k is equals to 7. 7 pi, it will become, I think it is in the fourth quadrant. So it will be positive. I'll have to write it as 1 by root 2. And along with that, what we are going to have is 2 power 7. This is the first bracket that we will have. Coming to the infinite GP, uska sum likhna hai, so that is going to be a upon 1 minus r, right? What is the next step? The calculation part only. You have to write it as 1. Then we have 1 by 2 root 2. So if you want, you can write down the denominator as root 2 by 4. The next term I can write as root 2 by 2 raised to the power 4. Then I can write it as minus 1 by 2 power 4. Then I can write it as minus root 2 upon 2 power 6. And then we have 1 by root 2 divided by 2 raised to the power 8. This will become 2 power 8 divided by 2 power 8 minus 1. Now it is a simple calculation part that we can complete. 2 power 8, you can multiply the whole expression over here. And we have 2 power 8 minus 1. So when you complete the calculation part, what you will be getting, let me tell you. Here we are going to get 15 multiplied by 16. This is what we will be getting the numerator. And plus 45 root 2. So how many root 2s are there? We will be getting 45 root over 2. Coming to denominator, it will be 2 raised to the power 8 minus 1. 2 power 8 means 256 minus 1 means 255. So I think 15 ko you can take common from the numerator and denominator, and ultimately your answer will reduce to 15 we have taken common. So numerator, coming to the denominator, it is 17. So here is the answer to this beautiful, small, cute question of the trigonometry. Hope you enjoyed it. So don't forget to hit the like button. Please share it with your friends and family, and obviously fellow aspirants, and do subscribe to our channel for more such content. Thank you all of you. See you in the next video. Till then, take care and bye-bye.